Okay, so in this video we're going to take a look at some of the conversions you need to do between quantities in solids and pure liquids. The first four symbols you should be familiar with: moles, mass, molar mass, and volume. Rho is a Greek letter which is used to symbolize the density, and then we use C for concentration, or else we put square brackets around the chemical to indicate its concentration. Now there's the units that I've written in red. I made a tiny mistake here. It's decimeters cubed, not decimeters to the negative 3 for volume. And again, the preferred unit I've written first. So the IB does prefer using decimeters cubed rather than liters or milliliters. And again, concentration is usually in moles, decimeters negative 3. Now for pure solids or liquids, such as ice or water, there are a few calculations that you need to be able to do. We're going to look at two in particular. So the first one that you need to be able to convert between, we've been practicing quite a bit, is this idea of converting between the mass of something to the moles and vice versa. And again, this is done using our molar mass. So for example, if we're trying to figure out the number of moles of something, we take our mass, we divide it by our molar mass, and one of the ways to make sure you're using the right formula is to make sure that your units cancel out correctly to give you the correct units. Here I have an example. I'm asking how much does 1.50 moles of NaOH weigh? So again, here we're going from moles to grams, and I've given you that molar mass again, which you could take a look at the periodic table for and add up the molar masses or the atomic masses of Na, O, and H. So in this case, relatively straightforward. I can use whatever formula I like as long as I get to the correct units here, and again I am isolating for mass and I get 60.0 grams. And again, if anyone is interested or understands sig figs already, here I have 3 sig figs because again that is the maximum sig figs that both of the numbers that I've been given have. The other kind of calculation that you're going to have to do in terms of solids or liquids that are pure is converting between volume and mass, and we use density. So for example, if you have a balance that shows this particular mass of H2O, the volume is the same in centimeters cubed because the density of water, rho H2O, is 1 grams per centimeters cubed. So converting for water is relatively straightforward. Between volume and mass, it's equivalent. And the good thing here is for aqueous solutions, so things dissolved in water, we can also assume the density is 1 unless otherwise stated. Okay, so let me just give you an example. I'm not going to solve it because I think it's relatively straightforward. Given unknowns compounds, density is 1.11 grams per centimeters cubed. How much does this many decimeters cubed weigh? So see if you can do that yourself using the conversion factor. Now you just have to watch out here because again my density is given in grams per centimeters cubed and my volume is given in decimeters cubed. So to convert between this, which you should become quite familiar with, you multiply by 1,000.